When we're talking about compound inequalities, we mean to say that we have two inequalities and they are joined together using the word and or. Just like a compound sentence is a sentence joining two sentences with and or any other conjunction. And we see that this word compound seems to be in lots of different topics. But in math, when we're talking about compound inequalities, we want numbers here that are greater than 10 and less than 18. So one way that we can do this, and one way that I would suggest to do this is, well, let's get a number line. And one way to do it is to, well, let's mark our numbers. Let's mark, well, first I'm going to mark 0. I'll mark 10. And I'm going to mark 18. And since we're talking about strictly less than, strictly greater than, then we're going to have open circles. Now you can see here that just by doing that, just by marking 10 and 18 on my number line is broken into three pieces. These numbers down here, the numbers in between, and the numbers up here. So I could choose a number from each one of these and test it to see if it works. So let me test x equal to 0. So if x is 0, does it satisfy x is greater than 10? And does it satisfy, well, let me go back here. If x is greater than, or excuse me, x is equal to 0, if we plug 0 into the first one, we get 0 is greater than 10. This is not the case. So since this 0 was a representative from this section, we're not going to shade this. Let's choose another number. Let's choose a number between 10 and 18. Let's say x is equal to 12. Is 12 greater than 10? Yes. So that works. So it satisfies the first inequality. It now must satisfy the second inequality as well. So when we plug 12 in for x, we get 12 is less than 18. It works for both. So now we know that it satisfies both, and that's what and, this word and, means. It has to satisfy both inequalities. 12 was a representative from the middle region here, so every single one of these numbers now is going to be shaded. And finally, if I chose, let's say, 20, if x was equal to 20, what happens? Well, I get 20 greater than 10. That works. So it works in the first one. Does it work in the second one? Is 20 less than 18? No, it's not. So since it didn't work in this second one, it doesn't satisfy both. We're not going to shade up there. So 10 and 18 are, that's where we're going to shade, right in the middle there. And just to review, if we wanted to write this in interval notation, it would be 10, comma, 18. And both of those would have parentheses because they are exclusive. We are not containing 10 and 18. It is strictly greater than and strictly less than. When we have compound inequalities using the word or, we don't have to be as careful as we were when we were working with and. And the reason why is when we were talking about and, we knew we had to find solutions that satisfied both inequalities. When we use the word or, we know that we're looking for solutions that work in one or the other. It might work in both, we don't know. But we just need to see what the solutions for the one set of one inequality, see the solutions that satisfy that, then look at the solutions that satisfy this, and then just put them together. And if they overlap, they overlap. If they don't touch, that's fine. But that's really what this word or allows us to do, is to just solve both of these separately and see what we get. So when I solve this first inequality, I will get, well, when I divide by 3, x is less than 10. That word or is being carried down, and now if I solved this for x, I get 4x is greater than negative 16. I divide by 4. I get x is greater than, let's see, negative 4. So on a number line, on a number line, I need to graph both of these sets. The set of numbers that are less than 10, well, let's mark 10 with an open circle. And I want all the numbers less than 10, so that's all the way down here. And I can now mark -4. So here's -4. I'm going to mark that with an open circle. And I want all the numbers greater than this. Now let's just look to see what happened there. What happened if I want a number less than 10 or I want a number greater than -4? Well, when we shaded that, it actually ended up shading this entire number line. The entire number line got shaded. So my solution set in interval notation would be -infinity to infinity. The smallest number that's shaded is -infinity all the way up to infinity. And you can just think about this. Think of any number you want. It can be any integer, any fraction, whatever it is. Think of any number you want. And according to this, whatever number you choose is going to be less than 10, or it's going to be greater than -4. So if I chose, let's say, 5 million, well, 5 million is not less than 10, but 5 million is greater than -4. So my number would be on this number line, and I urge you to try it yourself.